Good morning, everyone. My name is J. Surya. My topic is FM balanced slope detector. Uh, it is an improved version of slope detector. The drawbacks of harmonic distortion is removed in this detector by using two slope detectors instead of one single turned slope detector. Now we see the circuit diagram of a balanced slope detector. Um, the left hand side, the input of a FM is the transformer, and the output the voltage. So in this circuit diagram divided into two parts, slope detector 1, the upper part, and the lower part is slope detector 2. Next, the circuit descriptions. So already told, and the circuit diagram has two slope detectors. One is slope detector 1 and the slope detector 2. Now see slope detector 1. It consists of detector diode D1, filter capacitor C1, and load resistance R1, and the variable capacitor CT1. The variable capacitor CT1 is the turning capacitor because it is adjusted to the upper winding of the secondary winding of the input transformer T. Next, the slope detector 2. It consists of detector diode D2, that is the identical to D1. It has a filter capacitor C2 and load resistance R2, and the variable resistance CT2 are same on the slope detector 1. The turning capacitor CT2 turns the lower winding of the secondary winding of the input transformer T. Now the two slope detectors are balanced because the two capacitors are equal, and the two resistance are equal, and two diodes are identical to each other, and the upper and lower winding of the secondary windings of the center top transformer T are also identical. The primary winding of the input transformer is um, turned to the central frequency of the carrier signal Fc by using the turning capacitor Ct. The secondary winding are turned to the different frequency so that the circuit is scattered turned. The output of the detector diodes D1 and D2 are filtered by C1, C1 R1 and C2 R2 respectively. The voltage V1, which is developed across the R1, and the V2 voltage will developed across R2 are added together between the point E and F to get final output voltage V naught, which is modulating voltage EM. Next, circuit operations. The operation of the circuit can be explained by considering two slope detectors. So first, the slope detector 1. The resonating frequency of the slope detector 1 is 2f1. By adjusting CT1 so that it is greater than the Fc by the amount of delta F. As a result, a slope detector 1 is turned to FC, given as so the F1 considers FA. So the formula of slope detector 1, the FA equal to FC plus delta F. If considered the FE value is 1.33 into delta F maximum. Substitute the value of delta F maximum equal to 75 kilohertz. So the multiplied 1.33 into 75 kilohertz. So FA equal to 100 kilohertz. The signal coupled to the upper winding of the secondary winding of the transformer T as the central frequency Fc. If the maximum frequency derivation of the incoming FM signals RT is plus or minus Ft, the operation range of the slope detector 1 is between Fc and the Fc plus Fd. When the incoming signal frequency derivation between Fc and Fc plus Fd, the diode D1 is forward biased because the voltage Vd1 increased according to the frequency response of the slope detector 1. The diode rectifies the amplitude and the frequency modulated signal, the capacitor C1 and resistor R1, then the filter the rectified voltage. The voltage so developed across the R1 is the positive half of the modulating signal. This can be explained by the frequency derivation curve applied at the Fc on the frequency axis of that. The half positive of the frequency derivation curve lies in the response curve of slope detector 1. Therefore, um, the frequency derivation that are greater than are converted into corresponding amplitude by slope detector 1. So next the slope detector 2. So the slope detector 2 is turned to F2 by the adjusting the turning capacitor C2 such that so so take F2 equal to FB. So the formula is the FB equal to FC minus delta F. The FB, if considered, and the FB equal to 1.33 into delta F maximum. The consider also the delta F maximum equal is 75 kilohertz. So calculating the FB equal to 100 kilohertz. So the input FM signal whose frequency derivative lays between Fc and Fc minus Fd is converted into corresponding amplitude variation by the slope detector 2 because this part of the frequency derivation curve lies toward the frequency response curve of the slope detector 2. The voltage Vd2 developed across the lower winding of the secondary wind of the transformer T is amplitude and frequency modulated, which is across which corresponds to the frequency derivation from Fc to Fc minus d of d, and the voltage Vt2 is rectified by the diode D2 because it is forwarded bias and the capacitor C2. The filter this rectified voltage. The filtered voltage is developed across R2, and that therefore the output of the balanced slope detector is the negative half of the modulating signal corresponding to the frequency derivations lower than the frequency central frequency Fc. So now the combined response of slope detector 1 and 2. The output of the slope detector is the combined output of individual slope detectors. First, the slope detector 1 provides the positive half of the modulating signal across the output terminal E and F. When D1 is forward biased, the diode D is also slightly forward bias because the voltage developed across the lower winding is very small. This is because slope detector 2 is turned to the Fc minus delta F, while the incoming signal lies between Fc and Fc plus delta F. Therefore, when a positive voltage is developed across R1, very small negative voltage are developed across the R2. The sum of these two voltage appears between the output terminal E and F. The final output is slightly reducing by the negative voltage developed across R2. The formula of voltage is V naught equal to V1 minus V2. A similar action take place when the incoming frequency modulation signal contains the frequency derivations between Fc and Fc minus Fd. And the diode D2 is forward biased because the appreciable positive voltage Vd2 appears across D2. This is the because the slope detector 2 is turned toward the Fc minus delta F. The frequency derivation range lays in the negative half of the modulation signal. As the result, the voltage developed across R2 after filter the rectified output of D2 is the negative half of modulating signal. So the positive and the negative halves of the modulating signals are available across the output terminals of the balanced slope detector, marked as that the overall response of the both slope detector and the operating range at the curve is marked between the point K and L. This operating range of the overall response is straight line, and therefore the operation is linear. This removed that non-linear behavior of single-turned slope detector, and the higher harmonic are not generated in the balanced slope detector. The overall response curve take shape of the letter S. Uh, so this is the graph. Um, in the top of the figure is the models graph. Uh, so ta- so the upper curve is slope detector 1, the lower is slope detector 2. So the two common points of these two slope detector is 10 voltage, positive 10 voltage and minus 10 voltage. So so below diagram, it is the S curve. It named as curve or combined transfer curve or voltage versus frequency response curve. So in this graph, um, the graph are from the positive to the negative or negative to the positives. The shape is S. So the graph name S curve. So that the finally the advantage of the balanced slope detector. It is more efficient than the slope detector, and it is linear than slope detector. And finally, the drawbacks of balanced slope detector and the disadvantage. The disadvantage of the balanced slope detector is difficult to turn the three-turned circuit to different three frequency. The amplitude limiting is not provided, and the drawbacks of the balanced slope detector is the detector as the three winding in the input transformers, um, and all of them are turned to the different frequency. The primary winding is turned to the central frequency of the carrier Fc using turning capacitor Ct. The two secondary windings are turned to Fc plus delta F and the Fc minus delta F using the turning capacitor Ct1 and Ct2. The alignment of three turned circuits called staggered turned. It is difficult task that be completed with accuracy to obtain a linear S-curve. Next, the slope detector also responds to the amplitude variation of the input. Therefore, it is not provided to the true modulating signal, and the operating frequency range is increased, obtaining an S-shaped, but it is performed does not improved. So that's all. Thank you. Thank you, everyone.